Hello, welcome friends. Me Anila. The topic of my discussion is about ethanolic fermentation. But before this, don't forget to like and subscribe my channel and press bell icon. First of all, there are two types of respiration. In one type of respiration is aerobic and another is anaerobic. In aerobic respiration occurs in the presence of oxygen. Glucose is converted into carbon dioxide and water. In anaerobic respiration, which is also called fermentation, glucose is converted either into ethanol or either into lactic acid. If there is scarcity of oxygen, then glucose is converted into ethanol and carbon dioxide. This is known as ethanolic fermentation. In this video, I will tell you how to calculate numericals related to ethanolic fermentation. This is the equation for ethanolic fermentation. C6H12O6 is molecular formula of glucose. It produces 2 moles of C2H5OH, that is ethanol, and 2 moles of carbon dioxide. So it is completed fermentation of glucose into ethanol and carbon dioxide. Example number 1. If 20 gram glucose is fermented, what mass of ethanol is produced? So it's a simple numerical. We have the weight of 20 gram glucose is fermented. That means it is converted to ethanol and carbon dioxide. We have to calculate mass of ethanol produced. Solution. First, we will calculate moles of glucose, that is 20 gram amount is already given, divided by 180 gram per mole, which is the molecular weight of glucose. The moles of glucose are calculated to be 0.111 moles, where 180 gram per mole is the molecular weight of glucose. Since 1 mole glucose produces 2 moles ethanol, as I have discussed earlier, so 0.111 moles glucose produces 0.222 moles ethanol. Now moles of ethanol are calculated. Now we have to calculate mass of ethanol, that is 0.222 moles into 46 gram per mole is the molecular weight of ethanol. After solving, mass of ethanol is calculated to be 10.212 grams. So this is the answer of example number 1. Example number 2. If 30 grams sucrose is fermented, what mass of ethanol is produced? In this example, we have sucrose 30 gram. It is converted into ethanol. We have to find the mass of ethanol produced. First, sucrose is converted into glucose and fructose by invertase enzyme. Then this glucose and fructose enters glycolysis to form pyruvate, and then this pyruvate is converted to ethanol and carbon dioxide. Solution. First, we have to calculate molecular weight of sucrose. Molecular formula of sucrose is C12H22O11. So 12 is the number of carbon atom into 12 is the atomic weight of carbon plus 22 is the number of hydrogen atom into 1 is the atomic weight of hydrogen plus 11 is the number of oxygen atom into 16 is the atomic weight of oxygen. After calculating, molecular weight of sucrose is calculated to be 342 gram per mole. Now we will calculate moles of sucrose. 30 gram as already given in the example divided by 342 gram per mole. The molecular weight of sucrose after solving moles of sucrose is calculated to be 0.0877 moles. 1 mole sucrose produces 4 more ethanol. How it is? Because 1 mole sucrose produces 1 mole glucose and 1 mole sucrose, and 1 mole glucose produces 2 moles ethanol, and 1 mole fructose produces 2 mole ethanol. So overall 1 mole sucrose produces 4 mole ethanol. So 0.0877 moles sucrose produces 0.3508 moles ethanol. Mass of ethanol is equal to 0.3508 moles into 46 gram per mole is the molecular weight of ethanol. After solving, mass of ethanol is calculated to be 16.136 grams. Example number 3. If theoretical ethanol is 10.212 gram and if actual ethanol mass is 9.051 gram, what is percentage yield? So theoretically 10.212 gram and actual mass is 9.051 grams. We have to find percentage yield. Solution. For percentage yield, actual mass into 100 divided by theoretical mass, 9.051 gram into 100 divided by 10.212 gram. The percentage yield is calculated to be 88.64%. Example number 4. If the actual ethanol obtained is 9.051 gram and density of ethanol is 0.789 gram per ml, what volume of ethanol is produced? We have the amount of ethanol produced and the density of ethanol. Now we will apply the formula. Density is equal to mass over volume. So volume is equal to mass over density. We will write mass 9.051 gram divided by density 0.789 gram per ml. After solving, volume is calculated to be 11.471 ml. Example number 5. If 25 gram glucose is completely fermented, how many liters of carbon dioxide are produced at HTP? We have the amount of glucose that is completely fermented. We have to calculate liters of carbon dioxide produced at HTP, means at standard temperature and pressure. Standard temperature is 273 Kelvin. Standard pressure is 1 atmosphere. Solution. First we will calculate moles of glucose is equal to 25 gram divided by 180 gram per mole. Moles of glucose is calculated to be 0.1388 moles. As I have discussed earlier in the equation, 1 mole glucose produces 2 moles carbon dioxide. So 0.1388 moles glucose produces 0.277 moles carbon dioxide. We have calculated moles of carbon dioxide. Now we have to calculate volume of carbon dioxide at standard temperature and pressure. We will apply general gas formula. PV is equal to nRT. P is pressure, V is volume, N is moles, R is gas constant, and T is temperature. V is equal to nRT over P. We will put the value V is equal to moles, 0.277 moles into value of R. We will take that value of R which is in atmosphere, liter, mole inverse and Kelvin inverse unit. 0.08201 atmosphere, liter, mole inverse, Kelvin inverse into temperature is 273 Kelvin divided by 1 atmosphere is the standard pressure. After solving, volume of carbon dioxide is calculated to be 6.201 liters carbon dioxide. So, in this way we can ferment sugars. So, sugars such as sucrose first converted into glucose and fructose. This glucose and fructose undergoes glycolysis to form pyruvate. In the presence of oxygen, pyruvate enters Krebs cycle and carbon dioxide and water is formed. In the absence of oxygen, pyruvate is converted to ethanol and carbon dioxide in ethanolic fermentation and lactic acid in lactic acid fermentation. In this way, we can ferment sugars. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.